Hi, my name is Abhijit Day. I run storage engineering for Veritas Technologies. We started our journey a couple of years back with OpenStack in mind. We are a company that builds software-defined architecture for the last 20 years, for bare metal, for VMware, and now we are on our journey into OpenStack-based private cloud. OpenStack is a great platform. We talked about in 6 sessions in Austin. We talked about coming up with a new product called HyperScale for OpenStack, which gives you a software-defined architecture, a scalable platform for private cloud powered by OpenStack. A solution that we are coming up later this year in November, a month away, which is a controlled release of the product. This product provides enterprise-grade storage, scalability and performance for mission-critical Tier 1 workloads. It also provides insights into your cloud infrastructure. It provides live migration based on direct attached storage, commodity storage. OpenStack is not DAS aware today. We bring it to OpenStack. And it also provides a differentiator, quality of service, an end-to-end quality of service, from spindle, from guest to spindle, all the way to spindle. What is quality of service? It's a performance-based isolation of a multi-tenant application, so your Tier 1 workloads can run and eliminate that noisy neighbor from running, right? So we're bringing all these capabilities into OpenStack into an end-to-end storage, resilient, high available DR and backup solution for OpenStack. That is called HyperScale for OpenStack. We talked about quality of service in Austin. Quality of service provides application SLA. What is your minimum IOPS you want? What's your maximum IOPS you want? It gives you a way of effectively utilizing your available storage in all tiers of storage. It gives you congestion control. It tells you what are the IO dependencies in my distributed scale-out architecture. And finally, it gives you a sense of prioritization of data management. That's quality of service for storage. Now, essence of this call today is looking at residual IOPS. Now, what is residual IOPS? What's the big deal? Residual means what's left. Residual IOPS means what kind of IOPS are left in your storage device, your DAS, SSDs, which you can recoup. So the idea is, if I'm one physical node and I have 2 commodity storage device, flash disks, and I am running out of storage, I have no more IOPS to service my applications. But hang a bell, there's other nodes. There's other nodes which might have that available storage. So can I go reach into the other nodes to get their storage? That is residual storage. When an application tries to run on one physical node, and that physical node is running out of any more IOPS in the commodity flash device, the idea is to place that application into another physical node where there are available residual IOPS. It gives you better storage utilization in a distributed cloud scale architecture. It gives you huge SLA guarantees. You can now service that application with IOPS which is residing in your DAS pool in a different physical node. And finally, you can optimize by dynamically load balance your virtual machines based on which physical node has more residual IOPS. That's the world of residual IOPS. This is something we don't have in the product today. This is we are building, and that's why this is a perfect community to present our architecture. Again, we are checking in our solutions, our code into OpenStack as a community participant from Veritas. For the rest of this talk, I'll let Ketan Nilangekar, my chief architect for HyperScale, walk me through, and Dhruv Bhatnagar is an engineer in the team who will walk us through the rest of the presentation. Go ahead.
Thanks, Abhijit. So let's take a deeper look into the quality of service implementation in HyperScale. So what it really gives you is the ability to schedule virtual machines in such a way that your VMs are placed in the best possible storage-aware location or storage-aware computes. So that helps in packing more VMs in the available compute space that you have, as well as optimizing their storage utilization on the computes that they're running on. Second is the noisy neighbor issue. Now here the problem is a certain class of VMs which are exceedingly noisy in terms of their storage traffic will keep overwhelming your application VMs, your tier 1 VMs for their and will compete against each other for their storage SLA. So this is one of the problems that storage our quality of service is designed to fix. The third aspect is the ability to dynamically load balance your virtual machines based on the available capacity, and Abhijit just spoke about that a minute ago. But we are using this ability to basically augment Nova and do live migration of virtual machines in cases where the available storage IOPs are not meeting the SLAs. Now let's look at what is there today in OpenStack in terms of scheduling and placement. So we all know we have these Nova filters which allow you to filter hosts based on your CPU memory and basic storage. Then on top of that, we also have these weighers which assign weights to these filtered hosts and select these hosts by their weights. Now you have two storage filters that are available today in stock OpenStack. One is the disk filter and the other is the IOPs filter. The current disk filter is basically doing its basic filtering on the available disk space. The IO operations filter is doing its filtering based on the concurrent IOs that are happening on the computes. But none of these filters look at the available hardware that is driving these storage IOs, nor do they handle the bursty IO scenarios where some VMs are generating bursty IOs. There's no way to normalize them in these filters, and hence they cannot provide the kind of SLA guarantees that are required for your tier 1 virtual machines. And let's look at this problem with an example here. So you have these three computes with the given capacities, and I'd like you to focus on the IO capacity. The rest of the metrics in these computes are more or less the same, but the IO capacity is something that we are looking at, and the IO capacity here is the available IOPS on that particular system. So once you place a few VMs on these systems, the available IO capacity or the in-use IO capacity obviously changes. And in this case, I wanted to focus on the red and the green computes. Now, in this case, the in-use IO capacity of the red compute is 195K, which means that the available is only 5K worth of IOPS. Now, in this case, if you get a virtual machine create request with a minimum IOPS requirement of 10K, then it is not wise to place this VM on compute 2. But we'll see what happens with the current filters. Now the current set of filters will basically filter on the basic properties, and you'll get the filtered host in this fashion. And the weighing system will then come into play, and it will assign the, compute 2 with a higher weight because of its available cores. But in this case, as we just mentioned, compute 2 is not really capable of meeting the SLA requirements for this VM. So we have a problem, and this is obviously a bad choice for this VM to run. My colleague Dhruv will now take over and will describe how residual IOPS based filter can solve this problem.
Thank you, Ketan, for summarizing the problem. So let's rerun the same experiment again, but with the residual IOPS capacity filter enabled. So what we have is the same computes, same set of computes, the blue, the red, and the green ones, with the same IO capacity as they had earlier. We provisioned the same set of VMs to bring these all these three computes into the same state where we had them in the last experiment. So essentially, compute 2 is just left with the 5K IO capacity, and compute 3 is left with 150K IO capacity. The cores of the red compute, it has 12 cores available, and the green compute is having 10 cores available. Now we are actually going ahead and provisioning the same VM as we did in the last experiment. This VM wants at least 5 cores of CPU, and it has a storage SLA requirement of at least 10K sustained IOPS. We go ahead and run our Nova filter, and this time the where goes ahead and chooses the green compute, which is having more IO capacity available, rather than instead of the result that we saw in the last experiment, which is the obvious choice here. So let's go a bit deeper and see what is actually happening under the hood. So we have the same set of three computes again, the blue, the red, and the green one. And we have our HyperScale IOPs filter running as part of Nova Scheduler inside the OpenStack controller. What is happening behind the scenes is that all these three computes are providing the residual IOPs capacity as a feedback to our HyperScale IOPs filter. Now this feedback is coming to this filter every 30 seconds. And the IOPs filter, the HyperScale IOPs filter, is going ahead and taking a moving average of these residual capacities that it's getting feedback from every compute. And then it's going ahead and using that moving average to calculate decisions, to calculate and make decisions. So let's say a VM placement request comes here. And if we rerun our previous experiment again, we see that the filter selected the green compute and provisioned the VM on the green compute. So the benefits of IOPS-based provisioning are many. We are just listing a few here. The very first and major benefit is that we have a guaranteed SLA adherence, the dynamic IO ingest capability calculation. We also try and address the difference in the capabilities of computes. We capture the trends to avoid the bursty workloads. And this can very well work for live migration workflow as well. So now I'll pass the mic over to Abhijit to shed some more light.
So we talked about this new product in Austin, all the features, enterprise resiliency, storage insights, quality of service, and now we are adding a residual IOPS-based provisioning. That makes the storage solution complete, and that's the next release of the product. And we are free. You can download the bits, try the software, and watch us in this space of enterprise class storage management for OpenStack. And we are also continuing our journey into containers with Dockers and Kubernetes. Thank you.